All right, good afternoon, everyone. I'm Colonel Mick McDaniel from the Air Force Chief Data Office. And on behalf of Ms. Eileen Vadrine, the Department of the Air Force Chief Data Officer, I'd like to welcome everyone here to this month's session of Innovation Connect. So today we've got two exciting presentations for everyone. I'm very excited to have presenters from Air Force Blue Horizons program presenting a topic that they will actually present to the Chief of Staff of the Air Force this afternoon. So if they have to peel off a little bit early, that's the reason why, because they've got an appointment with General Brown this afternoon to brief this the same project. And then also we've got a guest speaker here from SOFWERX. So very excited to have Mr. David Akers with us today too. So two exciting presentations. And definitely thank all of our presenters for being here today, and thank everyone else for joining us on this program today. So, the purpose of Innovation Connect is really to create a collaborative atmosphere for those working within the DoD to share and exchange ideas, and then also learn about efforts that are going on in other organizations, or develop new thought and, develop a cross-flow of information. I know that I've certainly learned a lot from the sessions that I've been able to attend and be a part of. And learned about new ideas, new programs, new efforts, new things that are going on within the DoD, and people just really getting after innovation and trying to do things in a better way. So because of that, what we would ask is, if you think, if you know of an effort that would be good for sharing the environment like this, we ask you to let us know, please. And in that way, we could extend an invite to a program that maybe you're working or some mission partners of yours are working, and we can share that information across the Air Force and really the DoD. So before I get into the introductions for the speakers today, just a couple of housekeeping rules. I think most folks know, but unless you're presenting, please keep your cameras on or off, and then your microphones on mute. That goes without saying. And then what we'll do is so the speakers are going to give a presentation, and then we're going to do, they'll take questions afterwards. So as you have questions throughout the presentation, please drop them into the chat function, and we as moderators will do our best to manage those and bring those up at the end during the Q&A session. So just please put your questions in the chat there. Also, should go without saying, but just refrain from advertising type questions on behalf of companies or the organization. So keep the questions focused on the topics. All right, our speakers today, as I mentioned earlier, we're very excited to have two fellows from the Air Force Blue Horizons program down at Maxwell. So Major Devin Messiker, in a previous position, started as here on the headquarters staff in the A2, A6. And she has initiated coordination with the CAO office on the future of GI ISR funding with ABMS, critical enabler to JADC2. She's got a wealth of experience on the staff, and then has served as an intel support crew, intel support to air crew, force protection flight commander to a contingency response wing, and an acquisition program manager, primarily in software development for a FLECMEC and JTF GTMO. Also with her is Major Benjamin Haruska, commissioned in 2008. The ROTC program at Georgia Tech, is a computer engineer specializing in cyber and qualified as a cyber operations officer. His previous assignments include AFRL, Air Force Materiel Command, the 70th ISR Wing, and he's got an MS in computer engineering from Georgia Tech, and also is a graduate of the Computer Network Operations Development Program. So obviously two highly credentialed operators and airmen and fellows now at the Blue Horizons program, just completing that program. So without further ado, Major Messiker and Major Haruska, I'll turn it over to you guys. Thank you.
Hi there, thank you. So we're going to start sharing our screen as soon as we can, but I'll kick it off with a little introduction. So thank you for those. Just case in point, I'm a PM Intel type. That's pretty easy. I go by Devo, and my partner over here is Coco. He is probably a 6'2" that has more time hands-on keyboard than anybody I've ever met. He also is a NSA trained hacker extraordinaire, and he's actually one of the coders on our project, which is really exciting. So let me present mode. There we go. And I'm going to stop my video so that somehow, got it. Oh, it's right here. Okay, well, we'll keep sharing. You can see me anyway. Hopefully nothing craps out on us as we go through, but I want to make sure that you can see the slides as we go. Oh, there it is, stop video. All right, so here we go. So we landed on Dagobah for a couple of different reasons. And Dagobah stands for Data Governance and Business Automation for Humans. But we were really trying to get after seams between the security and the usability of data. So if you think security on one end, I think more along the lines of, I want to cordon off and protect my data. With usability, I'm thinking, how can I consolidate and share it? Well, we devised a software solution that we hope is a blend of the two with a company called Raft, who's teamed with us on some pair programming effort. And so what we've decided this is kind of reticent of is more like a permissions bridge. And so one of the biggest problems we run into is sharing between systems, between platforms, between databases. And the permissions bridge is kind of acting like a bridge between all of those systems and clouds and platforms.
So to be clear about a permission, so think anytime a person needs to access a piece of data, there's a role that that person has in an application. There's some amount of sensitivity for that particular piece of data. And overarching the two, there's a policy that says whether that person may or may not access that particular piece of data. Now, our security paradigm in practice is oriented around systems and boundaries, which has complications when what we really care about is the sensitivity of data. So for example, if I want to take, just getting after just an example. So Devo and I both have some previous experience dealing with the POM and budgeting process. So if I wanted to do a POM analysis on the secret network, and I wanted to take non-PII data out of a personnel system and combine it with non-compartmented data from a very specialized ops platform, and I wanted to do that on the secret network for an analysis, then that would be very hard, because our default is to assume that all data from that system is at the systems level, instead of being able to break it up more granularly.
So there's an analogy that I like to use when I describe this for myself and for others. If you think about it, like if you were driving your car cross country, for example, and every time you crossed a state boundary, you had to re-register your car and get a new driver's license for that state. Nobody wants to go to the DMV that frequently, and that's basically how we share our data today. So every time we run into a system boundary, our permissions don't go with the data. So we're rebuilding the permissions as we move forward. So I want to take a look at the pyramid. So I'm adopting all of you as data nerds today. So hopefully some of you already are out there. But if you take a look at the pyramid, this is kind of the data science hierarchy of needs. And if you were building a house, you never would start from the rooftop down. But a lot of times our focus has been on AI, ML, predictive analytics. And so when you start there, it means that every time you try to do some of that analysis, it's a huge lift on the front end just to get to those predictive analytics. And we realize that there's a piece missing of access and aggregation. And not that it's missing, but it's very cumbersome and it's difficult to work with. We actually ran into, because we had the background in POM and planning choices, we wanted to get after analytics for better investment decisions going forward. And we realized that there's already people playing in that space. Rhombus Power is a company that developed the Guardian tool. And when we first were exposed to it, we thought, okay, so maybe they took a year to get this started. But what really happened is their access took 3 years. So back in 2017, a couple of majors decided, okay, we're going to do this planning choices analytics called the Guardian tool. And so they took backpacks of hard drives around to the different data centers, downloaded the data, threw it into their backpacks, and flew back to the Pentagon to start algorithm development. It was like the Pony Express version of data access in 2017.
So we've had quite the journey in our academic year. So our journey had many great people that we learned from and taught a few things too, which was fantastic collaboration. A couple of key ones I wanted to hit on as this slide populates. So Cygnus out of ACC does what we're talking about doing with this permissions bridge type approach, specifically for like the int level, so the classification and the intelligence type of data, and federates it for the intelligence community. Another example there, so NSA has got some great control of their data for their internal stuff, so all the compartments and interesting stuff there, and kind of solved this for that realm. Now, what we found is that all of these organizations that are shown here and the many others agree with us that even though that there are some loose solutions out there, that permission sharing is really hard. So the approach generally is that still just kind of containing it within a platform or an environment. And they also, as we've kind of elaborated on what we've done, have agreed that if our approach is matured and implemented fully, it could potentially be a panacea solution to this problem today. So in terms of implementation next steps, at the top there, the Chief Data Office was one of our key players that have been working with us the whole time. And they have an awesome data lab, as most of you know in this audience, that make, great scientists, data scientists that make projects like Project Brown Heron happen, and the Vault work every day. So expanding the scope of what they do to include more data engineering and software integration with stuff like Platform One could be a viable path forward. Alternatively, at the DoD level, there are recent mandates that demand DoD level sharing by default. So getting an implementation arm up at that level could also make sense.
So kind of to further some of the insights that we had, that we want to move forward and leverage organizations that have a shared philosophy to pilot something like Dagobah in the wild. And we had only from January, when we started coding, to recently getting ready to brief the CSAF as a part of our academic curriculum to actually get this off the ground. So in 4 months, we had a small team that really kind of nugged through, and the next step for us would be the pilot. Now, technology is ready, and we know we can do better. A lot of questions have been out there for us in the past of, oh, well, we might be able to do this in a couple of years. The technology will be ready by then, but it is ready now. And part of the nice thing about being a part of Blue Horizons is that the mascot we talk about is a snowmobile. And so a snowmobile is built by taking pieces and parts of existing capabilities and putting them together, and bam, you have a snowmobile. And so if it's the treads, it's the skis, it's the motorcycle engine, and now you're able to travel across snow. And so what we're asking is taking pieces and parts of capabilities that are out there, which we'll talk to in the next couple of slides, so that we can get after this permission sharing. And it's difficult because the Chief of Staff actually chartered our program to go after seams, SEAMS, so gaps between organizations, between technologies, between the commercial sector, and between the Air Force and the DoD writ large. And it's become clear to us that there's really not one organization that's implementing solutions to share data better. There's a lot of pockets of really good stuff that's happening. But across the larger DoD enterprise, there is a policy arm, and what they're missing is that implementation capability.
So something like where Kessel Run gets to fly at the speed of light to get new capabilities out at the operational level for the AOC, we're looking at what made us successful with this project in a short amount of time was direct access to that policy thing that Devo just spoke to. So getting a similar organization that's oriented around the strategic level for data would be kind of what we're talking about.
So this is a picture of our team. I hope there's some Raft folks out there who recognize their own mug here. But that's me in the middle, that's Ben above me. And then our other military coder is to the side of me. You can see with the Air Force logo, and that's Alex Grover, he goes by Tree. And then our RAF team has been really instrumental in getting us off the ground. And we were able to do quite a bit in 4 months. But I know there's enough tech nerds out there who are probably wondering, well, what did you actually do? And how does this actually work? And so I'm going to turn it over to Ben to kind of talk through that piece.
So what we're talking about, again, this is the permissions bridge approach. So from the bottom left, I'll kind of start there. So authoritative data sources. So no, there was no intent to recreate any of the master data out there, whether it's personnel or ops. So fully relying on external data sources as the source of truth for pretty much everything we're going to use for this policy engine we're talking about. So taking that static sets of data, and there's at least 2,800 systems out there. If you take there's a system called ITIPS that lists kind of as a catalog of data or systems for the Air Force. That lists 2,800 entries or so, and we know that there's more than that. So taking the authoritative data sources and turning those into something that's usable with this methodology. So there's a technology out there called event streaming. You might have heard of Apache Kafka as an open source project, or others that allow you to tap into these authoritative data sources, really the databases, and turn it into a stream. So whenever there's a change, so if let's say a rank changes from captain to major or something else, that one little change can be streamed out as an event, right as it happens, as opposed to kind of how it works today. In most cases, you don't know when a change happens until you query the database the next time. So it's kind of a push versus a pull approach. So to be clear, the bottom path that you see from left to right is that intent is that's all that push style. So you are going from authoritative data sources, turning it into a stream, going through our tagging processor, which I'll get to in a second, and then being able to reshare more than one tagged stream out to whoever else needs to consume it. Now, the reason there's more than one tagged stream is because my input might be somewhat sensitive. So I might have an input stream that's including maybe 50 fields in a kind of sensitive HR database inside MIL-PDS, a sensitive personnel database. Well, I can break that up in real time into different buckets of fields where some of them are widely releasable with everything, like let's say DOD ID number mapped with first name and last name, and that's it. And other ones that might have more sensitive data but still generally out there, that includes maybe organization, rank, and email address. And then other ones that get a lot more sensitive, like social, home address, mother's maiden name, all that kind of stuff. So I can have different buckets of granularity in my sensitivity and send that data out with fresh tags. Now that's not the whole thing. That just applies tags. Now I have groups of data. So the rest of this permissions bridge is kind of oriented around that API that's in the top right. So after I've sent this data out with a push, I have an API available kind of from a pull, and that lets external systems ask, okay, for this user, based on this tag, how do they have access to this particular entry or record or not? And that is based entirely on a graph-based model that we've developed. It basically implements policy-based access control, and it's stored in our reference implementation and uses Neo4j, but you can use any graph database to make it work easily. And the reason that we oriented around that as a part of the solution was that there are many different security paradigms. How you want to secure PII versus, let's say, classification data or higher compartments of classified data. The rules and how that works looks different. The policies and structures of that looks different. A graph database lets you model those however they need to be modeled, and ultimately flatten them back out into a tag, and then an API that allows you to answer those questions of whether a user has access to a particular tagged set of data or not. So I think with that, you want to do another one?
No, I think that's good. I just wanted to call attention to, we're excited to jump into some of the questions, but I did want to mention there was a SecDef memo that was pushed out to talk about the decrees to ensure that data is joint in all domain and shareable. And if you haven't gotten a chance to see that, there's a great C4ISRnet article about it that we saw this morning. And I was happy Ms. Vadrine was able to send us the memo, and so we could actually read through the decrees. And it gets after that culture piece. I know when we talk about sharing things, a lot of times we get wrapped around, well, the culture isn't there for us to share. And I think it's pretty awesome that we have senior leaders that are stepping forward in the policy realm to change that culture. I think the next step for us, and what we hope Dagobah offers the way forward, is the tools to allow people to share with security in mind, understanding that they have assurances going forward that as they share the data, that security is going to go with it. And with that, I'd like to turn it back over to all of you to pepper us with questions, poke holes, demand more information, what have you. So I'll go to the chat now to check that out, and I'll stop sharing too. Sorry.
Yeah, it looks like just one question about where we can get access. Yeah, well, the slides will be posted and there's a Confluence link.
Yeah, please keep the, everyone, please go ahead and post any questions that you might have in chat, and then we can get those over to the presenters. So I'd like to ask a first question. So you guys talked about organizationally some of the things that you found when you went and discovered a lot of different, it sounded like a lot of different efforts across a lot of different organizations, but not everyone was particularly empowered to kind of take the policy and make it and put it into practice. I don't know if I captured that correctly or not, so please correct me to 100%. But taking that, what would you say, or what are some recommendations, or what are some of the conclusions that you guys were able to come up with based on that experience?
Yeah, that's a good question. So just to be, I guess, to be specific, most of the time, every different application or data environment can model their permissions inside the system however they want. That's just the commercial standard, is not to try to share it. It's just to encapsulate the data in your application, in your piece of software. In the DoD, that doesn't work that well. So when you try to just have one system to rule everything else, like there's no one organization in the government that owns the scope of all data. So it's not really the same approach. So we kind of have a unique reason to solve the problem in a little bit more of a federated manner. What we could do, though, is standardize around a specific, standardize is really the right word, to standardize our approach to permissions policies, and then develop a publishing mechanism to be able to federate it. That's incredibly important for any of our prototyping to work, is that those authoritative data sources, for example, on that graphic to the left, bottom left, how do we know that they're authoritative in the first place? And how do they know that they can infer, like, how do they know that they can work with the system? How do they publish to the system? Those are big pieces to know. So when we did our prototyping, we delved all the way into the data raw, and that's an approach. It's a much more cumbersome approach to do that. We had to kind of dig through the different tables. We used MyVector test data just for test data, it's not an authoritative source, but it's just data we had available to us, and it's very rich. So in order to kind of build our policy inside, we needed to go in through the tables and figure out how it was, applying the different users to different roles to different permissions, and then we could add on after the fact. There's probably a better way, but this was the prototype we came up with. But ultimately, publishing this stuff across the enterprise with like an enterprise registry is the most important approach, I think.
I think it might be interesting to mention too, like, I think most of our problems that we run into today is, that there's legacy systems out there that we have a hard time tapping into. But if we are able to kind of pull the data out of them, it gives us an opportunity to use some of those systems in a different way. In every day, I mean, anybody who works up at the Pentagon knows that you're going to get questions from Congress about data, about information that you think should really just be at your fingertips, but it's not. And the number of taskers that we have to deal with is pretty insane. But if you were able to actually access the data, even from legacy systems, to answer questions you never really thought you'd ever get asked, that's what we're talking about. It's a paradigm shift in how we think about data. Instead of things built to be shown in a database, we're building them to share routinely. There's another question here, Ben, and someone missed the start, but they're asking if tagging happens while the data is in flight or while it's at rest.
Yeah, for our prototype, it happens in flight. So there's nothing that says that if you conform to like that publishing thing I mentioned before, that you couldn't tag it at rest in an origin system. It's just, we kind of came in with the premise that we didn't want to recommend that every one of those listed systems had to all refactor and kind of meet this standard. So, and there's technologies that are available. It's called change data capture. And then there's connectors that let you turn a database into the stream. So it allows us to do it in flight. And so that's how we prototyped around it. Ultimately, you could do it either way. And then I think I see another question about was it a single IL or across the guard? Yeah, so we only had four months to prototype. So, and that was an interesting challenge for relevance to, like, let's say the classified systems and going cross domain. So we oriented around our problem solving around approaches that would conform without limiting our ability to actually progress and solve the real problem. So we were only at IL2. In fact, most of our developments and prototyping has been offline, but still standing up a database, streaming data, and then tagging it and checking it out. So yeah, it's all the same sensitivity level. There's ultimately policy shifts that would need to happen that allow you to do this kind of event streaming and push it through a guard. That stuff's not in place. And so there wouldn't be something to plug into today if we tried to prototype it that way now. But yes, it was just at IL2. And then another one, so you mentioned dealing with sensitive data. Yeah, so is encryption an option? Yeah, so the idea here is because the tagging is off to the side, or I guess the tagging model is off to the side. Once you've approved a group of data that you want to tag, you don't actually have to have decrypted data in order to do the tagging. So you can have fully encrypted data and add a tag on it that's then in the clear and pass it along. So it allows you to do end-to-end encryption without getting in the way.
Identity classification aggregation concerns.
Can it help identify classification aggregation concerns? Yeah, so whenever you federate data in any way, this is kind of outside of the prototype. But yeah, if you federate and share data in any way, and you're doing more robust modeling of what the permissions actually are, then yes, you could feasibly, digitize your security classification guides and kind of analyze that as compared to what the permissions models are and look for conflicts. I think that was the question, but if not, please chime up on audio as well, and feel free to.
If we're missing a piece of that, please don't hesitate. Oh, we got a yes.
Okay, awesome.
Good. We're glad. Does anybody else have any other questions? I mean, we're happy to dig in, even if you have a question about Blue Horizons or our process, how we came about here, we're more than happy to chat about it.
Guys, it may be helpful to drop your contact info in the chat session, and then that way folks, if they have any follow-on questions, can go from there. Yeah, perfect.
We got it in there. So I'll attach a quick one page or two, and then I can send out I think our Confluence link is posted.
Yep.
Is there anything? Oh, she got it. Okay.
Yeah.
Thank you, Angela. I'm happy to entertain some more questions. We're actually briefing the Chief of Staff later today, so we'll see what he thinks about this. We have a couple of asks for him too. If anybody else wants to give us some advice, we'll take it to the boss.
Yeah, so that's a good question. So Mr. Stroud asked, did it account for group A, which is unclassified, and group B, which is unclassified, but A and B is classified? Yeah, so if the origin system was at the unclassified level, and then aggregating them together is classified, this is an authoritative policy mechanism, assertive. It's an assertive policy mechanism. So when the analysis is done ahead of time, this is an automated thing. Like it's not an automated policy building part, right? The automated is in the tagging. So when the policies are built, we would need to account for it ahead of time, at what point your aggregation is classified. Ideally, you'd start from the most sensitive element at that IL level or that classification level, and then work backwards. And then if the data is originated outside of that system, you just keep it at that system and don't move it up. But yeah, there's lots of ways to model it, but it's definitely got to be an assertive approach. There's nothing automatic about aggregation, like assumptions about classification.
What's next? So there's a couple of things that are next, I guess. We want to leverage an organization that has a shared philosophy. We actually have been working with Dr. Say Schatz up at the Advanced Distributed Learning. And most of the time up at the DoD, you have a lot of policymakers and then not an implementation arm. And so we were lucky to find an effort that is focused on learning systems across the DoD. And bringing them together, and they're interested in helping us prototype Dagobah out in the wild, and we're trying to help her see how logistically how to make that work. And
then again, we mentioned continuing to work with the Air Force Data Lab under the Chief Data Office, and then at the DoD level too with the Chief Data Office up there. those are both approaches we're continuing. We're both graduating and moving on, but we're not letting the effort just die. So
yeah. And if the what's next is about what we're doing next, I'm going to be going to Air Force 10 Cap, working tactical exploitation of national capabilities in Colorado Springs. And Ben?
I'm going to be the director of operations for the 33rd Network Warfare Squadron down in San Antonio under the 16th Air Force.
If you work there, let us know.
Well, thank you very much for all of your attention today. We appreciate the time and love to being here. Thank you.
Awesome.
Great opportunity.
Hey guys, thank you very much for spending time with us today. So best of luck on the presentation with the chief. You guys have done a fantastic job this past year. So congratulations on wrapping up a huge project. And thank you very much for your partnership over the past year. I know it's been good for our team as well. And we've appreciated partnering with you guys, with Blue Horizons program. And then, just learning a lot through this whole process.
Yeah, if you're a captain, major, or lieutenant colonel out there and you have plans for ACSC or Air War College and you're interested in what the heck Blue Horizons is, please reach out to Ben or I. We'd be more than happy to share with you our experience.
No, awesome. Thanks, guys.
All right, thank you.
All right. Okay, so that is fantastic. So thank you guys, appreciate it. And again, best of luck on the brief, on graduation, and your next assignments. So our next presenter is the Senior Program Manager for SOFWERX, Mr. David Akers. He works closely with small, non-traditional businesses to identify new technologies that support the needs of US SOCOM and other government entities. So Mr. Akers has military leadership experience from the platoon to the brigade level, and has built and test flown multiple experimental aircraft. He holds an FCC license with radar endorsement, a commercial pilot's license with nearly 1,000 hours as a pilot in command, over 1,000 hours of combat aircrew time, in a Part 107 UAS commercial license. So Mr. Akers is the founder of two nonprofit organizations focused on delivering aviation-focused STEM education to disadvantaged students. We are very pleased to have him with us today. So Mr. Akers, thank you for taking time out of your busy schedule, and we look forward to your presentation. So I will turn it over to you, sir.
All right, thank you, sir, and thank you for the kind introduction. We appreciate that. And so we want to talk a little bit today about one of the projects we've been running for about 2 years for a special mission unit in coordination with RRTO and US SOCOM. But before I get into that, I wanted to talk a little bit about SOFWERX and kind of what we are, just for those folks on the line who may not have a good understanding or may have some presumptions of what SOFWERX is. But we just want to make sure that it's clear, because it seems as even when we get out to the tenant units under SOCOM and so forth, there's a little confusion sometimes, particularly as they look at us and it's like, oh, are you like AFWERX? And it's like, well, kind of, but not really. So what I want to do today is, like I said, stop off on kind of what SOFWERX is all about, and then we'll get into some really cool technology that we call what's the Autonomous Biosensor Infused Triage and Treatment System. We call it ABITTS because it's quite the mouthful. So with that, I'll get my face off the screen and I'll start the brief. All right, so in terms of SOFWERX, what is it? So really what we are is we're a platform. We're cradled under Title 15 as a partnership intermediary agreement with US SOCOM. And we believe in the big tent philosophy, where we go out and we seek the academics, the non-traditionals, the citizen scientists, the hackers, the makers. We kind of try to pull everyone together that what we consider as non-traditional DoD partners and help get them funneled in to help solve SOCOM's specific problems. And a lot of times, most folks, particularly as a citizen scientist, the small companies, they can't even spell, FAR, let alone how to engage in the FAR process. So by being able to engage in business-to-business arrangements and working somewhat outside the FAR, not to get around it, but to help grease the process into it, that allows us to really accelerate things into the SOCOM S&T process specifically. Yeah. So in terms of some of the things that we've done over the past 5 years now, I mean, we've worked with about 407 component requests. We've done about 80 TSOC or soft unit specific requests. And then we've worked about 41 projects specific to the PEOs. And of those, just to kind of give you an idea of the breakdown, we've done about 238 individual projects, about 78 collaboration events, 37 assessment events. And when I speak assessment events, that's where we'll go out in the industry, we'll pull, white papers, quads, all that stuff in, we'll package it, we'll hand it off to the PEO or the warfighter. We allow them to do the selection process, and then we execute on the backside. And by doing that, that allows us to become a neutral facilitator, because we never want to get into the process of, choosing winners and losers. That function solely resides within US SOCOM, but we do everything we can to help enable them. We really see ourselves as an enabler in that aspect. And in terms of the type of technologies we seek, we're really in that almost that adjacent type, because you're incremental. The PEOs, they can already do that. They can go out and they can find the next, best sniper scope, or they can improve, range on a weapon or something like that. And transportational, the transformational technology is really what S&T and DARPA and some of the other agencies are working out, which are more long-term, heavy research dollar focused. And so we go out and we look at what's already exists in the wild in the commercial sector, and it's like, how do we modify, how do we tweak this algorithm, or maybe change some kind of interface on some other component so that it can be quickly put down range to help the warfighter. And again, we really see ourselves as kind of the differentiator in terms of the FAR-based process, just because we can move so quick. One of the things that we've been able to do working with Ms. Sanders over at S&T is go to Congress. Well, she went to Congress and got an exemption to allow us to pilot a cyber program to where we can execute some level of cyber on her behalf during this 3-year pilot. And what we're able to do, and what normally takes about 3 to 4 months to execute a cyber, we're doing it in days. And we've shortened the cycle time down to about 24 months, where typically it's 48 or better going into that phase 3 or towards the OTA side of it. And then in terms of the velocity of that, we're able to execute multiple contracts simultaneously, which is a real big benefit to SOCOM as well. And just hold any questions relevant to SOFWERX, and we'll come back to that. But we're going to go ahead and get into a little bit about the ABITTS now. So it's a pretty interesting program. Like I said, it started with the Special Mission Unit. They had a need for something that, as they were looking or supporting Talos JADF about 4 or 5 years ago, like, hey, how can, when the operator gets wounded or something like that, how can we monitor that? How can we monitor their physiological functions? How can we provide the command element better, C2, understanding, how our formation's doing, how to cross queue information, and then also looking, is there a tick, knowing, different statuses of folks, not just necessarily if there's an injury or a wound, but just also in terms of, max exertion and some other things. And then on the backside of that, if God forbid that someone does get injured, is there ability to provide source of treatment, particularly in either a remote or a automatic fashion, particularly for gunshot wounds, being that hematinic loss or shock, anaphylactic shock being the primary cause of death in a combat type situation. So that's kind of the genesis of where the project was born out of. So SOCOM, JADF, the end user got together with RRTO and formulated a project that was really focused on those specific efforts. You can go ahead and go to the next slide. Okay, and so some of the things that they really wanted to look at is, number one, is it completely feasible? And they wanted to draw up a con-op that really reflected the needs of the end user. They understood that there would have to be some pretty significant algorithms developed to accomplish what they wanted to do, because they not only wanted to identify penetration wounds, but exit wounds, and also caliber type. And in order to do that, it would have to be impregnated in a garment. So they looked at a range of thin films and threads and so forth. And as we go through the presentation, we'll look at some of those different ones, and I'll provide you a little bit of the pros and cons and things that were discovered over time, and what the final state is towards the end of the presentation. They also had to have something that would interface with ATAC that had the capability to do some of the things that were already in some existing apps, but would run simultaneous. To include being able to pull in vitals and so forth, and then also feed into things such as BATDoc, FALOC 9 lines, and some other things. And then they also wanted to look at the wound treatment framework and how that would work. And if bladder pressure or some type of other chemical type agent would be best suited in terms of blood loss stoppage and things of that nature. Next slide. So really what they were trying to do is come up with or focus on a sense, signal, and treat type system. And so that was the philosophy carried throughout the program. Go ahead. So during the con-op phase, a lot of time was spent just really trying to understand what's the best way to articulate the information not only to the warfighter, but how to push it up and down the echelons as well, and then across to medics or adjacent units. What information would be discoverable, what information would remain solely on the device, and then also looking at the patient information as well, and what could and couldn't be shared, and how to obfuscate it for anonymity, capture situations, all those things. Next slide. And they also spent quite a bit of time looking at the just the projectiles and how they perform. There's a lot of data out there, but they couldn't find any algorithm type work that had been done in the past based on what they were trying to accomplish, specifically being able to detect velocity and so forth with a single penetration of the thin films. And they were primarily looking at the energy transfer and some other aspects. Next slide. So after they captured the data, they went out and they started building some crude prototypes. And the photos on the screen there are literally some of the first prototypes that were built, and along with the coding and the bladder system. They primarily looked at compressed gas to inflate bladders, and and then the actual well, I can't get into the details of this particular slide, but they did some live tissue type stuff at with some local hospitals and things to determine where best to place it, how best to place it. And one of the things that came out of it is that they found that there was some percentage of false releases of the bladders. And there was some serious concern at the point of the end users going forward with implementation. So at that point, they decided to drop that part from the project until a later time that they could focus better on a chemical type effort versus bladder control. They spent quite a bit of time laying out the garments as well, determining how best to situate the patterns for a number of reasons. Primarily as they looked at vital and non-vital type wounds where body armor would fall, and then also wearability, flexibility of the virus patterns. So next slide. As they developed the different thin films and the different textures, one of the, well, there's two actually key things. One being the IP rating, or how well it could hold up in water, wet environment, and things like that. But the other was the durability with washability, and a third being manufacturability. I can go back. We'll go back. All right, I'll just talk to it. So they had quite a time going through the different sensors because it was very easy to 3D print something on fabric, but then the durability wasn't there. And then if they looked at using, for instance, silver threads, titanium threads, and some of the other types of substances, the issues became the amount of energy that it would take to fracture them, thus triggering an event. And it took about 66 different evolutions to come to two that worked fairly well. The first being an actual individual single thread woven throughout the fabric, but the downside was the manufacturability aspects of that. And then the second being a specific thin film composite that actually works pretty well, and is what they're continuing to refine now. As part of the phase one, also, we wanted to do a pre-demonstration over at MacDill prior to put it in front of the end user due to the availability of the end user. Essentially, we didn't want to waste their time. We didn't want to put something in front of them if it didn't have a real promise. So we set everything up for this particular instance. This was early on. There was essentially a single sensor for enter and exit. On the center photo there, those are double backed. You can't really see the backside there. And they're just basically one thing. It's not four quadrants, just one single cell. And they were using the hexoskeleton shirt to get both respiration and heart rate for the vitals. Although the ability exists to use like the Phoenix 6, Garmin's Phoenix 6 watch, and other Fitbits and things like that. And this particular user wanted no Bluetooth or emissive type connections. So the hexoskeleton provided a USB link hard connected to the USB hub. And the demonstration was pretty successful at MacDill. It detected all the shots. So we moved forward to prototyping some shirts to take out and do the first end user demonstration. You can see there as they're going through the manufacturing process and putting on an actual T-shirt. It was pretty flexible for the most part, and performance was about 85–90%. We went up to Virginia Beach and did the first demo. The user was pretty happy. The big thing is that they wanted to expand at that point to 8 sensors, 4 in the front, 4 in the back, for each of the quadrants. And there was also an emphasis on reducing the size of the circuit board. You can't really see in these pictures here because the controller boxes are out by the targets downrange, but they were about the size of maybe about 5 or 6 decks of cards, approximately connected to an MPU 5. And the end user was adamant that they need to be no larger than a single deck of cards. They wanted it placed on the upper back, just below the helmet, but just above the IBA line, so that it was out of the way and wouldn't affect them running, swimming, etc. So that was a lot of the focus from phase 1 to phase 2, along with integrating into the user-defined specific fabrics. They didn't want a t-shirt, they wanted the outer garment for a couple different reasons. The medics drove a lot of that in terms of just they're going to cut it off anyways, and just the durability and some other things. And then one of the questions comes up, okay, well, what if he gets, snagged or, stabbed with a knife, things like that. The algorithm's smart enough to know if it's a rapid type of wound versus like a snag or a tear. And then it also gives manual override as well before it would broadcast it out into the system. And they also wanted expanded coverage just beyond the 4 squares of the center of the torso, where the SAPI plate 6 to go beyond that to essentially give 360 coverage for the upper torso, and then also in the groin and upper thigh areas as well. Those aren't really depicted in the photos because it's kind of tough to illustrate, but it does provide additional protection to just above the knees. Next slide. And upon all those integration efforts, we went back and did the final user demonstration in May of 2019. We also had AFRL on site, folks from WritePat. We did the first integration of BATDoc. We also did the initial integration of the 9-line CASVAC process. The system worked very well in terms of being able to identify entrance, exit, shots, all that stuff for the 5.56 and 7.62x39. However, it was deficient in the 9mm and shotgun rounds. It's kind of interesting what we found, even though the spacing between the sensors or the films were about 1 millimeter to 1.5 millimeters, the 9mm round, due to the shape and the velocity, would actually push through the thin films, failing to detect. And a similar thing was occurring with the shotgun rounds. Even when we used buckshot, it was very seldom that we would actually get positive registrations, or it would just tear a big hole and cause multiple failures rather than being located to a single location. The slide went on, but also on the bottom right on the slide before, it showed the new puck, which was again about the size of a deck of cards, but about 1.5 thick, a much better improvement. Based on the final demonstration, we had a lot of good user feedback. We also had 75th Ranger Regiment. We had some other government agency participation in the debrief as well to help provide guidance into the phase 2, in that the effort was worth pursuing. So the second round, or the phase 2, was kicked off a few months later. Again, that was a partnership between ROTO and SOCOM with a cost share. And I put it on just to show the real benefit of when you have multiple agencies working together. It can lower, the cost risk profile and go a long ways in terms of advancing the technology. This was originally scheduled to be a 1-year period of performance. However, due to the COVID impacts, it's continued to extend it. We'll talk a little bit about that in a second as well. The phase 2 effort, so was really just pulling in that fine user input and improving for ruggedization, and do the full integration of the BATDoc, and to complete the full integration of the 9-line CASVAC as well. And here are some photos of the miniaturization of the circuit board. This is the 2nd generation. And then also the fabrics. It's a little tough to see maybe on your slideshow there, but instead of going with the straight line thin fabric, they ended up going with the little squiggly line, using some machine learning and some modeling, and they were able to solve the problem with the 9mm, the buckshot, and some of the other subsonic round detection issues that they were having before. And then in the center, the puck, or the sensor there, is not quite as large as a hockey puck, but very thin, only about 4 or 5 millimeters in thickness, significant improvement. Next slide. And they also did a significant amount of ballistics modeling as well. And this goes back to helping define the specific the parameters for the thin films to really determine what was the best solution to detect all rounds 100% of the time, because that was the number one requirement for the specific end user, is that 100% shot detection 100% of the time. And what we have here is the latest generation of the interface. As you can see that it's gotten quite small. It's migrated to a USB-C. The bottom left and the top right are black and white with the original round puck, and then the top left, bottom right are the latest iterations. It's very low profile, extremely light. It's only about 30 grams or so. And again, the USB-C now, everything's it's powered through the USB-C now as well from the hub versus having an internal 1, 2, 3 battery. So the battery power of the life will essentially last the length of the mission as long as they have radio power. And they're also continuing to do durability testing. This is as of a little over a month ago up in the Northeast. I mean, taking out, run, jump, roll around in the snow. You can see in the top center, top right, doused in water, driving over it. A little hard to see in the bottom center, but he's shooting it with a 9mm there, and it's getting positive detections every time, which is a tremendous improvement. Next slide. And the integration of the fabric itself has improved significantly as well too. Now it's essentially a thin coating on the inside of whatever user-defined garment is selected or chosen by the end user. In terms of thermal properties and so forth, because of the spacing, it's still breathable. So there's no issues in terms of retention of heat in hot weather environments, for example. And so really, kind of the next phases, we have a tentative demonstration 8, 9 July with that particular user. And they also pitched this past Tuesday to some OGAs. I know the FBI and some other organizations are interested as well for their HRT and some of the other teams. So with that, I mean, that's really kind of an overview of the project. It's pretty interesting because it's integrating a lot of different technologies in terms of, the fabrics, the algorithms, kind of pushing the edge in terms of the electronics, microelectronics, and so forth. So be happy to answer any questions or, receive any feedback you may have.
All right, Mr. Akers, I think some questions are coming across the chat. So if you want to just take a look at them as they come across the chat, we can do that.
Okay, yeah, it says the heart rate and respiration rate displayed on the app coming from the garment itself or a different set of sensors. So not from the garment itself, the garment would be whatever the normal BDU uniform or whatever the case may be is. So for the biometrics or for the heart rate, respiration, and so forth, either comes from, if it's hardwired, from something like a hexoskeleton shirt, or it can come from, like I said, like the Garmin, Phoenix 6 type watch or some type of device that the end user is currently using. It just depends on whether they need to limit their EMI radiation based on the mission.
Awesome, thank you.
So the garment limit mobility at all? Is there anything the wearer needs to be conscious of while wearing? No, because the garment is essentially whatever their uniform is. The system's integrated into the user specified garment. Washing wise, the minimum requirement was 10 washes. Right now they're getting in excess of 20 in testing. And the wearability of the fabrics and so forth is whatever the limitations are of that specific garment. Right. So did you run into any privacy concerns when handling the data generated by the garment system? No, that was part of the, there was a lot of time and discussion on that, particularly as how do we feed into BATDoc and how do we segregate personally identifiable information. And without getting into the details, all of that was solved so that if a casualty situation happens, the relevant information is provided both, to the 9-line and to BATDoc without identifying the patient, and then the reconciliation takes place once they hand over, to the medevac bird. All right. Do we have any other questions?
No, I'm sure that there's some more questions out there. That was a fantastic presentation. So just a very cool technology and innovative approach to doing a really awesome and important task and mission. So something you'd expect to see from Stark Industries or Tony Stark, come up with something like that, the technologies that you guys are looking and developing in real time.
It's very interesting. I mean, because the technology is there to do a lot of cool things, but then we get into the philosophies of, okay, does the ground force commander have control, and he makes the decision on what stays within the team, or does the jock have control? Who sees what, when? How do you push those authorities back and forth, and things like that? So it's very interesting as we go through these developmental processes and see how it shapes policy and procedures up and down the echelons.
Yeah, absolutely. And should drive new doctrine. I mean, technology like this will drive new doctrine, maybe new command and control structures, and really changes a lot about how we conduct operations, I'm sure.
Yes, and it helps a lot with triage too, because now the medic can, see, say they, you got a dozen guys out there, different states, he can tell what their vitals are. You can set alarms specific to the individuals to determine, who is the most urgent. I mean, someone maybe have 2 gunshots, someone else may have something else, but they may be more critical. So that also helps with the triage situation as well. We haven't been able to do the auto cast. That way, the inbound birds, they know, who needs what their condition levels are, and so forth, so they can be better prepared when they land.
Yeah, I've seen similar data and information be demoed in other forums too. So it's clear this is a concept that's in demand, and but I am sure that whatever partner you were working with on this, there are probably many other partners out there that would be looking for similar capabilities. So, and across all lines of across many different applications. So,
yes, sir. All right. Anything else from the audience? All right, and we'll put our information up there. If anyone has any information or any questions, we're happy to share what we can. And if we can't, we'll put them in contact with the appropriate folks on the SOCOM side so they can get what they need on other classification levels.
Awesome. Hey, thank you, Mr. Akers. This was a great presentation, and just really, really cool stuff. So you've got an awesome job. Sounds like you've got a really fun job, and opportunity to make a big impact, and so that must be extremely rewarding.
It is, sir. Thank you. I appreciate it. And please come visit if you ever get the chance to get down here in Tampa.
Believe me, I would love to do that. I would love to do that. I'm sure everyone on this call would. Okay, so thank you, Mr. Akers. Again, thanks for your time and sharing, and thanks for putting your contact info in the chat. So if you have any follow-up questions for Mr. Akers and some of the work that they're doing, but what an awesome problem that they're trying to work to solve. And a lot of great thinking and sharp intellectual thought is going into that, and what a great impact. So thank you. Okay, so that concludes this month's Innovation Connect. 2 really great presentations, a lot of good stuff going on out there, and a lot of good thought happening within the DoD, within the Air Force, and within the DoD. So thank you again to our presenters. I know our Blue Horizons folks had to peel off, but Mr. Akers, thank you very much again for your time. Thanks to Ty, Lindsay, and Callie for putting this together from our team. You guys always do a fantastic job, and thank you very much for allowing me to host. So I'll put in a plug for our next month's session. Right now we're looking at June 10th for our next month's session, and so we have on the docket, we have a brief from Project Brown Heron here within the Air Force. Looking at COVID readiness data applications and analytics for decisions throughout the Air Force. And then also we still have open topics. So if there is another program out there, we could get someone else on in June. If we do have room to get someone else on in June. So contact us if you know of a program, or if you have a program that you might be interested in. So hey, I'll ask Ty to put our contact info in the chat session. And our how to contact us at SAFCO. But again, I'll just close with thank you very much for your time, everyone, and thank you for joining us today. The more folks that we have on these calls, the better. And I appreciate our presenters, organizers, and our participants. And I wish you all a great Thursday, and have a great Innovation Connect today. Thank you.